Welcome to today's lesson, section 9.1a, Vectors in Two Dimensions, part 1. Here we're going to go through a majority of the terminology or vocabulary that we have for this chapter, and then kind of just the beginnings of it. Now, for vectors, if you had physics, most of the stuff will be just review for you. If you're not, then this will be just kind of new. But vectors are just kind of like rays. They are a line segment that have an assigned direction. So they look like this thing down here that I've drawn, where it's got a kind of an endpoint and then there's an arrow. So that's what it means, assigned direction, kind of like a ray. So there's not an arrow going in the other direction for A, or towards A, but it is going towards B. So there is an initial point, which is the starting point. So in this case, it'd be A. Terminal point would be the ending point. In this case, would be B. Okay. The magnitude is going to be the length of the line segment for the vector, and we can say vector AB. We'll usually use a short value or letter to represent this. So usually we'll use U's and V's to represent our vectors. We can use other letters, but those are the main vector letters that we usually use. Okay, so just so you're aware. Now, one thing to note is that two vectors are equal if they have equal magnitude and they have the same direction. Okay? So what I mean by that is if, let's say, so when we're writing them, they have, so this is like a distance of 2, and then they have to have the same direction. Now the direction is indicative of like the values that we use, so we'll talk about those here shortly. So when we are dealing with vectors, we can add them, okay, and we can subtract them. So like U and V, I can add them, I can subtract them, but which is the same thing as adding the negative of the other vector. And to do that, we use something called component form. So in component form, if you have a vector V, it's going to be represented in the plane with a point P x sub 1, comma y sub 1. So that's like your initial point. And then your terminal point Q, which is x sub 2 minus or comma y sub 2. Then we'll write it as kind of a ordered pair, but instead of with parentheses, we use arrows. Okay, and so they're like L ones. Okay, so kind of like going back up here, if you wanted ones that were the same direction and magnitude, they would have to be like 2, 4 and 2, 4. So these would be the same magnitude, so they have the same length, and they have the same direction. So they have the same x value length, and they have the same y value length. Now, some of these could have the same direction, but not the same magnitude. So let's say if I took out one of these and made it 1 and 2, okay, these have the same direction. Okay, so even though there's different values, so let's make a mini xy coordinate plane right here. Okay, so let's say we start at 0, and so this is telling me my x, this is telling me my y. So from that point, if I go over 1 and up 2, then I have this direction of 1, 2. But then for the other one, if I go over 2 and go up 4, that gets me right there. Now, even though one is longer, so they have different magnitudes, so different lengths, but they are going in the same direction, so they can be equal like that. Also, another way of getting this to be true is if they have different starting points, but they have, like, if this is 2, 4 and another 2, 4, but one starts at 0, 0 and another one starts at, let's say, 5, 6, then they have the same direction and magnitude, but they're just at different spots, basically. Okay, so there's multiple ways of that happening. And so to find your vector, you would subtract your x's and you would subtract your y's. Kind of like distance formula almost. Okay, so thus vector v, which is a comma b, is where your a is the horizontal component, so the x value, and b is the y component, or vertical component, so the y value. Okay? So let's try some of these. So here, example 1, we want to find the component form on the vector u with the initial point of -2, 5, and the terminal point 3, 7. So if I want to find u, that means I need to subtract my x's. So terminal minus initial, and then same thing, terminal, which is 7, minus initial. Okay? So here, double negative makes it positive. So 3 plus 2 is 5. 7 minus 2 is, 7 minus 5 is 2. Okay? So then that would be my component form for this example. Okay? Now let's say we have one of those points missing. So if you're given the vector and you want to find the terminal point given the initial point, then how would you go about finding that? So here, if you know your vector v is 3, 7, remember that's equal to your x2 minus x1 and your y2 minus your y1. Well, you know one of those points, right? So you know your initial. So there's your initial x, and then there's your initial y. So if you set up equations to do that, so 3 equals x sub 2 minus 2, and 7 equals y sub 2 minus 4, then you can solve. So add 2 over. So x sub 2 must be 5. You added 4 over. And then y sub 2 must be 11, so your terminal point has got to be 5, 11. Okay? Now, we've been talking about magnitude and what that looks like. To find magnitude of a vector, you will take, it's kind of like, we don't really take the absolute value there, but we use double bars, and sometimes in notes we use double bars to notate magnitude just so you don't get confused. So we might do that, but just know in the book, when they're talking about vectors and magnitude, they will use just like absolute value bars. Okay, so I tried to kind of use absolute value bars so you got used to thinking about it that way, so that when you looked at the book, you didn't get confused. But just know that these two things, if you see these are the same thing when we're talking about magnitude of a vector, and we're not really taking the absolute value. Okay, so it's almost like solving for like a Pythagorean identity, where you take the square root of a squared plus b squared to find the hypotenuse side, basically. So if I'm looking at this vector 5, 4, then I want to be able to take square root of 5 squared plus 4 squared. And that gives me 25 plus 16. And then 25 plus 16 is 41. And so then that would be my magnitude. Also for the other one, if I took -3 squared plus 2 squared, then that would give me 9 plus 4, and that would give me a square root of 13. Now, not all of them are in radicals, but some are, so don't get thrown off if you can't simplify them at all. Okay, since you are adding perfect squares to each other. Okay, I'll see you in part 2. Have fun.